Okay, so when we want to do factoring, one of the methods that we teach is a diamond problem, which basically goes back to the days when I was teaching CPM. It was a type of a problem that they would show kids early on in the year to get them used to the idea of factoring. And what they would do is they would create a box like this, and the top box would be a product, the bottom would be a sum, and then what they would look for is two numbers that have a product of 6 and a sum of 5. So again, that works well when we're factoring x squared plus 5x plus 6. And so obviously those factors or those numbers are going to be 3 and 2, which then we go ahead and put our polynomial or our quadratic in factorable form, write it as a product, and we end up with 3 and 2. Okay, now bottoms up is kind of a variation of the diamond problem, and this is one of the few things that I'll do that is just blatantly an algorithm. I never really even get into the kids on how it works and why it works and stuff like that, just because once we get to factoring, I just kind of want, it's just a means to an end. But basically, you're looking at a quadratic that has an a value other than 1, and all of the terms need to be relatively prime, so you have to have factored anything out using the distributive property. But the difference with the diamond problem is instead of the way you find your number that you're going to find the product of is you multiply the a and the c values, so you get 6. So now we're looking for two numbers that multiply to 6 but add to 7. And so those numbers are going to be 6 and 1. Now, they go into the factor form like they normally would, but the difference is now we have to go through and divide those values by a. And then we reduce the fractions. And so once we reduce the fractions, if you have a denominator still, you bring that denominator and that becomes the coefficient of the x in that term. So that's where we get the name bottoms up. So we just take the bottom of the fraction and it comes up and becomes the coefficient of that new factor.